Hey guys, welcome to day 3 of our unit 1. We're still in our reasoning and solving basic equations unit, but today we're going to look at something that we call dimensional analysis. And if you're like, what in the world does that mean? Then that's good. That means you have something to learn. Okay, I'm just going to start off with a couple questions, and they're right here on your paper. It says, what is an inch, foot, meter, yard? Well, what do you mean? What is an inch, foot, meter, and yard? Well, this is a type of measurement. We could all agree on that. Okay? If we measure something in inches, feet, meters, or yards, we're usually trying to measure the size of something or the distance of something. So we can start off by saying this right here, these are measures of distance. Measures of distance. And number 2 says, well, how long is a second, a minute, an hour, a day, a week, a year, a decade? Wow, that's a lot of things that I'm talking about right there. But they're all measures of what? That's right. They are all measures of time. Now, sometimes we measure things in different measures of distance or different measures of time, and sometimes we have both distance and time in the same measurement. Like when you drive a car, you drive miles, that's a distance, per hour, that's a time. Okay, if we're just measuring something like the size of your bed, we're just going to measure distance, and you probably don't want to measure in miles when you're measuring your bed because that's just silly. Okay, you probably want to measure in inches or feet. Okay, when you're measuring time, you're going to use a different type of measurement depending on what you're measuring. If you're going to talk about how long each class period is, you're probably going to measure in minutes. Okay? If you're actually going to talk about how long the school year is, you might measure that by how many days we're in school or how many weeks we're in school. Okay? So we're going to use different measures of distance and time when we talk about these dimensional analysis. Okay, now, can we change, so this is right here underneath it, can we change from one measurement to the other? So if I give you something in inches, can you change that to feet? Of course we can, because we all feel very comfortable that we know that there are 12 inches in 1 foot. Okay, we feel very confident in some of these measurements. We could do feet to meters or inches to yards. It would just take a little extra steps. Same thing with our time. We could change weeks to minutes, and we could find out how many minutes are in that week or how many seconds are in a day. Okay, one of the easy ones is we all know that there are 60 seconds in 1 minute. Okay? So the more difficult we go, the farther apart we spread those measurements, the more work we have to do, which is what we're going to talk about today. Okay? When we are describing real-world scenarios, we have to consider the appropriate measure. So kind of like I was talking about, your bed, you are not going to measure in miles. Okay? So let's look at example 1 here. It says, if you were asked to describe how old a baby is, what measure would you use? Okay, some of you guys might have a younger sibling at home, maybe a brand new baby. If you think about this, when you're talking about a little baby, are you going to measure that in months? Probably not. Okay, are you going to, well, you might measure in months, but not right away. Right away, you start measuring by weeks, and then you move to months. And then once you hit 2 years old, 3 years old, that's when parents typically start going by years. So for a baby, we could say we would probably measure in weeks or months. Okay, when they turn to a toddler, we probably start measuring in years. Okay? But what about a dinosaur? So the second part of that question says, a dinosaur. Am I going to measure a dinosaur in how many weeks old they are or how many months old they are? No way. Dinosaurs are super old, right? Yeah. So if we're going to measure dinosaurs, we probably want to measure them in years. Does anybody else have a better idea? We could also measure them in. Did anybody think maybe decades? Decades are every 10 years. Okay? So if we said someone was 2 decades old, that's 20 years old. Okay? So we could do years, we could do decades. If the dinosaur is really, really old, we could go even bigger measurements, but we'll just start with years and decades. All right, what about example 2? A turtle is crossing the road. Stop for a second. Think about a turtle crossing a road. Do turtles cross? Do they walk fast or are they pretty slow? So what would be an appropriate measure for his speed? Now, there's one really, really important word right here, and it's this: speed. Okay? We need to make sure that we understand speed is always a measurement of distance over time, or distance per, right? We could call that line per, like miles per hour. Okay, it's always going to be a distance over a time. So let's first look at our choices and get rid of the ones that don't give us distance per time. So the first one, A, says miles per hour. That's distance per time. The next one says hours per mile. That is not distance per time. So I'm going to cross that out. C says seconds per mile. Well, seconds is time. Nope. And D says millimeters per minute. Now, think about miles per hour and millimeters per minute. Which one of those is going to be the best to tell us the speed the turtle is crossing the road? If the turtle crosses the road really small, do we want to measure in a big distance like miles, or do we want to take a smaller distance like millimeters? Okay, I would suggest that we want to use the smaller distance of millimeters, because the turtle is going to go a smaller amount of distance per the time. So the best appropriate measure would be millimeters per minute. All right, so let's get into talking about how we actually convert these. So to convert between units, we can use what we call dimensional. Oops, be helpful if I spelled it right. Dimensional analysis. Okay, so that is just the process that we use to convert between units. So if we're going to convert from minutes to years, we're going to use the process called dimensional analysis. Okay, well, we're also going to talk about something called a conversion factor. Well, what are conversion factors? Conversion factors are equalities and they are arranged as a ratio. Okay, hopefully you remember what a ratio is. A ratio is a fraction. It's a fraction that's going to have different units. Okay, so we can just take a breath. Ratios are okay. They're just something we are going to set up as a fraction. All right, so let's talk now about the actual steps that we're going to use in order to do our dimensional analysis. The first thing that we're going to do is we're going to write down what we're given. Okay? Then the next thing that we're going to do is we are going to write down the conversion factors. Okay, these are going to be any of them that we can use. So like if it's 12 inches per every 1 foot, then we're going to write that as a ratio, as a fraction, because we want to make sure we can see all the things that we can use to help us get where we're going. Number 3 is then we actually get to write it out to show that we are going to multiply. Be helpful if I remember the L, sorry. We are going to multiply by the correct conversion factor. So we're going to look at the ones that we have, figure out which ones are the correct ones we need, and we're going to show that we're going to multiply. I use just the multiplication dot. You want to use the multiplication X, that's fine. Then the last part that we get to do is really fun. We get to cancel the units and do the math. So let's look at what that looks like for something that's pretty easy that we could figure out without doing these steps. So 7 days is how many hours? So right off the bat, we know we need to go from days to hours. Okay? Well, we already know something of a relationship between days and hours. So hopefully in your head, you're already telling yourself that you know that 1 day is 24 hours. So this is a unit, this is a conversion factor, okay? But we want to start with what we know. So the first thing that we know is we have 7 days. And we need to take this conversion factor and show that we're going to multiply it. Now, the trick here is that if days are in the numerator, because essentially we could write this over 1. If days are in the numerator, that means, oops, I need to put days in the denominator. So that means this conversion factor we wrote, I actually need to write it with the 24 hours on top and the 1 day being on the bottom. Okay? So what this is going to allow us to do is to do this cancel. We can cancel out days because a day over a day cancels. Really, that just leaves us 7 times 24. And we can figure out the answer. If you need to use your calculator, that's fine. 7 times 24. That's going to tell us 168. 168, well, what is that? Hours. Okay, that's the only unit that's left is hours. So 7 days would be 168 hours. Right? How many ounces are in a gallon? Okay, so this one's going to take a few more steps because we need to go from ounces to gallons, or from 1 gallon to how many ounces. So if we start with 1 gallon, we need to be thinking through what do we move through next. Okay, well, the next smallest thing that we can go to from a gallon is a quart. And how many quarts are there in a gallon? If you're not sure, guys, I put a bunch of conversions on like the next page over. So flip on over, look at the conversions. We should know that there are 4 quarts in every 1 gallon. So that means my conversion factor is going to have the gallon part on the bottom so it can cancel, and the quart part on the top. And we just said there are 4 quarts in every 1 gallon. So notice now our gallons are gone, but we still have to get quarts down to ounces. Well, the next smallest unit we can move to is pints. Okay, there are 2 pints in every quart. So remember, we need the quarts on the bottom so it cancels, and the pints on the top. So there are 2 pints in every 1 quart. So our quart is going to cancel. Now we got to take pints down to something smaller. Pints can go down to cups. So we need the cups on the top and the pints on the bottom. How many cups are in a pint? 2. So pints are gone. And now we can move down to ounces because we know that there are 8 ounces in every 1 cup. So that means all we have to do is multiply across the top and we get 128 ounces. Let's take a really small break and then we'll come right back.